Howdy, my name is Von Chow, and my partners are Vincent Conley, Damian Pierce, and Jason Lau. And this is our boat project, our group. We have 4 people in our group, as per the names I mentioned before, and I'll say it again. My name is Von Chow. Partners are Vincent Conley, Damian Pierce, Jason Lau. Our duties are pretty much evenly divided, with sometimes one doing a little bit more work than the other, but honestly, that's fine. We sometimes have busy schedules. We had little to no problems in the group. Sometimes we had miscommunication, and more often than not. But we overcame this by communication and on iPhone. One of our hardest challenges was how and where we would meet up. Because of our busy schedules, it would be pretty hard to meet up, and we could only do that on like 1 o'clock Friday, somewhere in the library, and some of us would show up, but we managed to do it quite well. Abstract. What is this project about? This project is about exploring the possibilities of artificial intelligence within marine ecosystems and chemistry. Our project is basically about how AI would integrate within the ecosystems and chemistry of it. So something like using AI to track the chemical reactions and the pH levels within the sea, or using AI to manage ship crews and stuff like that. Initial proposals: preservation of endangered species, wave/tide patterns, logistics of maritime transportation, causes and effects of natural events, and ocean acidification and marine pollution. These are all of our proposals that we created a couple months ago for our deliverable, one of our deliverables. And yeah, I'll leave it to the next person.
Okay, my name is Vincent Conley, and this is my part of the Chem Lab presentation for Chem 117. In the top left, or scratch that. In these slides mainly apply to the maritime logistics portion of our project. And in the top left, you'll see one of the many boats that we encountered on our chem trip that occurred a few months ago. And in the bottom right, you'll see a GPS system that many of these boats have. And this GPS system is necessary in order to find where the boat needs to go and have the boat be able to do its original purpose. Now, you see that boat in the top left, and there are aboard many boats, which is why having a good form of maritime logistics is important. And going back to our abstract and the point of our entire project, it shows why AI could be implemented so that we can use AI and we can have sensors and whatnot that allow our boats to maneuver about each other without any fear of collision. Now, on the second slide, we have pictures of 2 bridges that could also we could also implement AI to automate them. Because currently, I believe they're both manned. The top left one might not be because it is the train bridge, and trains generally have good logistics behind them. But I know that the bridge that we use to get onto Galveston Island has an operator because you have to radio in, and that would be a lot more efficient if there was a boat and a proximity sensor and a computer program that we could use to lift up the bridge. And AI could be implemented to make it a lot more efficient overall.
Hello, my name is Damon Pierce, and I'm the research facilitator for this project. I make sure my group members had beneficial and effective research. So, in this slide, I'm going to be talking about supportive resources. So, Big Blue Ocean Cleanup and the Ocean Cleanup are a few of the several nonprofit ocean organizations that uses AI technology and I'll talk a little bit more about the Big Blue Ocean cleanup in the next slide. So for our first source, from an article from Marine Technology News, states that AI helps track ocean acidification by monitoring pH level and other relevant parameters. Machine learning algorithm can analyze large data sets generated by these sensors, identify patterns and trends in ocean acidification over time. In our next slide, I'm going to be talking about scientific evidence. So in an article by the Big Blue Ocean Cleanup, they talked about using AI to detect databases of photos which can depict plastic and pollution. They also talked about a lot about AI robots which can be designed to repair damaged infrastructures, and also discover several new species to help aid future medicine for illnesses. The article also mentioned Hypergiant using AIs to monitor algae growth, adjusting conditions such as pH level, light, and temperature to optimize growth. This particular strand of algae excels in absorbing carbon and aiding in reducing ocean acidification.
Hi, my name is Jason, and I'll be talking a little bit more about how artificial intelligence fits into marine and chemical applications. So, how is this problem affecting the marine environment? And we put atmospheric chemistry and how current vessel routes can be risky to marine life, and also natural and artificial disturbances. So, atmospheric chemistry is a study of composition and chemical reactions that occur on our Earth's surface, like in the water and the atmosphere, and it involves gases, like chemical processes that influence winds, tides, and climates, and so this includes like the ocean atmosphere interactions, climate change, and sea level rise. It's actually directly linked to climate change, which has widespread implications for the marine environment. Rising atmospheric concentration of greenhouse gases is, that's what's causing global warming, and therefore the sea level rises, the changes in ocean temperatures, and the alterations in natural marine ecosystems. Like vessel traffic can also pose collision risks to wildlife, oil spills, noise pollution, and disturbances in habitats. So next we have large-scale data collection. This is how engineers can handle these problems. We can develop systems to clean and process information, and we can optimize marine restoration initiatives, and this can all be done through intelligent systems. So actually quickly and efficiently dispatching resources to distressed areas is one of our biggest goals. This is extremely important in a process where time management is critical. And AI can quickly analyze various factors such as wind speed, sea currents, fuel costs, to optimize routes for efficiency and cost effectiveness and minimize travel time, avoiding congested or high risk areas. Some of our ideas to overcome these problems. Many causes and effects of natural environmental processes can now be recorded and mapped using modeling. These are technological innovations that have risen exponentially in the past 10 years. Recording causes and effects of environmental processes. The more data you have, the safer something will be, because you have history supporting it. Finding less harmful paths through the water to minimize or mitigate risk for us and sea animals. And then and here are some of our references.